areas between curves and lines. So let's get a lesson objective down, and we're going to investigate how we find the areas that are bounded by curves and lines. Hit pause, copy the lesson objective down. Okay, so if we have a case such as this one, where we have a line y1 and a curve y2, we've got an area here that's bounded by y1 and y2. How do we calculate that area? Well, what we do is we find the area underneath the line, y1, like so, it's a trapezium, and then we find the area underneath the curve, and we subtract them. The area underneath the curve there, subtract it from the area underneath the trapezium, subtract, and that leaves us with the area under the curve. The area bounded by the curve and the line, rather. So we can see this as the integral of y1 minus the integral of y2, and we can combine both of them between the limits of a and b. So we have the integral of y1 minus y2 as one equation with respect to x. Okay, hit pause, make notes on that, and if you want to sketch the diagram before, but I think this should be enough. Once you've done that, we'll look at an example. Okay, so let's have a look at this example here. We've got a sketch of a curve and an equation. The curve is y equals x times 4 minus x, and the line is y equals x. So we want to find the area bounded by the curve and the line. We need the limits. Now we can see that they intersect at the origin, but they also intersect at this point here. So how do we find the coordinates at that point? Well, I've got two equations and two unknowns, y and x. Where they intersect, they're going to be equal to each other, so I can equate. Oops. You didn't see that? Equate, let's call this one 1 and this one 2. Equations 1 and 2. So we got x times 4 minus x is equal to x. So expanding on this side, I've got 4x minus x squared is equal to x. I'm going to bring my x squared to the right hand side and leave my x's on the left. Actually, I tell you what, I'll take everything over to the right hand side. 0 is equal to x squared minus 3x. Factorizing, I've got x times x minus 3. So therefore either x is equal to 0, which we know when x is equal to 0, y is also equal to 0, or x is equal to 3, which means y is also equal to 3. So we got 0, 0, and 3, 3. Important that we know the x coordinate. Right, so to find the area, what I do is I take my curve, find the area under the curve, and I subtract then the area under the line. So the area under the curve is given by x times 4 minus x minus the area under the line, which is x with respect to x, forget my brackets, and my limits, I'm going from 0 to 3, integrating that, well, simplifying first, integrate from 0 to 3, and I get 4x minus x squared minus x with respect to x, which is equal to the integral of 3x minus x squared with respect to x. Now I can integrate, and that leaves me with 3 over 2x squared minus x cubed over 3 from 0 to 3, and substituting for 0 and 3, I get 3 over 2 times 3 squared minus 3 cubed over 3 minus, that's going to be 0 and 0, so minus 0. Simplifying, I've got, what have I got? 27 over 2 minus 27 over 3, which is equal to 13 and a half. This looks very familiar. Minus 9, which is equal to 4 and a half. And that's just the area, so it's square units. Okay. So I'd hit pause, get that example down. Once you've done that, hit play, and we'll look at another. Okay, in this example, sketched over here, I've got to find the area between the curve and the line, but it's just the shaded region there. So what I'm going to do to find that is I'm going to find the area of this triangle here. It's a right angle triangle, OBC, and I'm going to subtract this small region here. That'll give me my shaded region. So area of the shaded region is going to be equal to the triangle OBC, so the area, the triangle OBC, minus the region ABC. In order to do that, I need to find the coordinates of C first, where they intersect. So I've got my two equations again, equation 1, equation 2. So we say equation 1 and 2 intersect where x times x minus 3 is equal to 2x. So we solve, we equate and solve. X squared minus 3x is equal to 2x. So subtracting 2x from both sides leaves me with x squared minus 5x is equal to 0. Factorizing and solving, x times x minus 5 equals 0. So either x is equal to 0 or x is equal to 5. Okay, so we know that's 0, 0. When x equals 5, you know the y equals 2x. So it's going to, y is going to be equal to 10. So we've got coordinates 5 and 10 for C. 5 and 10. Put that in our diagram. Right. So let's find the area of the triangle in the first instance. Just switch color. Of the triangle. Now, area of a triangle is base times height over 2, which is equal to the base, well, that's 5 there, times the perpendicular height, which is 10, divided by 2, which leaves us with 25. Square units. Now we want to find the area bounded by this region here. So all we need to do is find the area under the curve from 3 to 5. Just going to switch pen again. We have area under the curve from 3 to 5. We find that by integrating then from 3 to 5. Our equation x times x minus 3 with respect to x, which is equal to, we can integrate, well, let's simplify it first. 3 to 5 x squared minus 3x, brackets with respect to x. And when we integrate that, we get x cubed over 3. Oops. Just rub that out. That's better. X cubed over 3 minus 3 over 2 x squared. That's going from 3 to 5. So if we sub in, what have we got? Subbing in, we get 5 cubed over 3 minus 3 times 3 over 2 times 5 squared. Minus 3 cubed over 3 minus 3 over 2, 3 squared times 3 squared. Let's make that clear, it's times. And we need to solve that. That leaves us with 125 over 3 minus 75 over 2 minus 27 over 3 minus 27 over 2. Common denominator is going to be 6, so you should end up with 25 over 6 minus 27 over 6. And that leaves us with 26 divided by 3. Now, so the area, the shaded region, is going to be the area of the triangle minus 26 over 3. I'll just change pen. Blue. Shaded region. Therefore, OAC is equal to 25 minus 26 over 3. And that will give us 49 over 3. So hit pause and copy the example down. You just got to be aware of what we're trying to find. In this case, it was that shaded region. So we could use a regular shape, a triangle, which we've been finding the area of for a while, and then subtract the area under the curve there. That was all we needed. Okay. Hit pause, and I've got some questions for you. Okay, so we've got exercise 13G. I think we've got, what have we got? 11 questions. Okay, and we've come to the end of integration. Good luck.